All right, guys, welcome to another episode of Cuda Education. Today we are continuing down our path of learning Apple Metal, which is the computer graphics framework um, for the Apple ecosystem. It also tangentially deals with AI stuff, neural network stuff, machine learning stuff, things of that nature. But for the purposes of my channel at the moment, I'm focusing on computer graphics. All right. So we've been pounding the pavement for a while, and going through code and going through a bunch of stuff. But we need to step back and just kind of go through a couple of raw definitions about what specific terms are, why we need them, what their purposes are, all of that good stuff, right? Um, the terms that I want to tackle today, and the reason I want to tackle them, in this episode is because in the following episodes I'm going to deep dive into each one of them, in more granular and specific terms. But you guys need to know what they are, what the big picture is, why we need them, you know, and use that as your spotlight, if you will, so that when we get deep into the code and into the granular stuff, that you aren't lost or lose interest and all that good stuff. Okay. So the first thing we want to get into is a compiler, and what is its purpose. Then we want to get into the pipeline, the graphics pipeline, and what is its purpose. Then we want to get into the render pass and what is its purpose. And then we sort of want to figure out how they're all related to each other, how they link up with each other, all of that good stuff. So a compiler. Let's start with a compiler. A compiler is a tool that translates human written programs into machine executable instructions. So, for example, you have we have code here, and we're writing a bunch of instructions, pseudo English, if you will, but we're writing a bunch of instructions. We have variable names, we have colons, we have equal signs, we have brackets, all of that good stuff. The thing about it is that the GPU doesn't, as fancy as these GPUs are, they don't understand the written word. The GPU fell asleep in English class, or it fell asleep in many classes actually, and we have to boil down all that we do into machine code. Um, the most basic of instructions, zeros and ones, and you string zeros, a specific lineup of zeros and ones, and that might mean an if statement in human language, but in machine code it's zero and one. I don't know, two zeros and then five ones is like an if statement. I don't know, right? But that is what a compiler is, just generally speaking, in plain English, right? Now, in terms of computer graphics, it turns shader code and pipeline descriptions into something the GPU can actually run. We'll get into pipeline, definition next, but it takes your shader code and pipeline descriptions into something the GPU could actually run. So basically, all of the code that we developed, whether it be, um, you know, instructions from the CPU side, or instructions from that we have on the GPU in the form of shader code, or just the general instructions of how we want to run the application. What are the parameters of how we want to run the application, which sort of gets into the pipeline definition, and what are the parameters for how we want to go about getting stuff on the screen, right? So that is your that is your compiler definition. Takes human written programs and turns them into machine executable instructions that the GPU could actually play with and run with, right? Um, it's something in every program or every line of programming I've ever dabbled in, there always had to be a point where a compilation happened, right? Because whether you're giving instructions to the CPU, the GPU, the the web server, whatever it is, there's some kind of compilation that has to happen in the background. Now it could be hidden, where you don't realize that it's happening, but it certainly does happen, right? Because machines sort of speak in machine code, machine executable instructions and stuff. What a compiler is not. A compiler is not a renderer. So a compiler is not something that puts things on pixels on the screen. Okay, a compiler is not a renderer. A compiler is not something that runs every frame. So every frame that's produced, the compiler isn't involved in that for every frame. And it's not something that draws pixels, right? So getting back to, what I said, the compiler doesn't draw pixels on the screen, okay? Now let's get into what a compiler does in Metal or Metal 4, right? Specifically, like, for example, the triangle application that we've been working with, right? So what the compiler does, the compiler takes a shader function. So we have a vertex shader and a fragment shader, right? It takes the pipeline description, which we'll get into a definition of the pipeline next. It validates compatibility. So of course you have to make sure that, all the instructions and all the things that you're doing, that it's sort of compatible with everything, right? It's compatible with the other things that we're going to talk about. It's compatible with the GPU, all of that stuff, right? The file formats, the the assets, the things that we're using, it all has to make sure that it's compatible. And if it's not, compilation fails, right? And this is a big part of programming in general. People write elaborate things and do elaborate things, but when they try to compile the program, compilation fails, and they don't know why. Okay, so that's a thing to consider for the compiler. It generates GPU specific executable state, right? So yeah, I mean, this, you could think of this as like your .exe file. So give me the executable file, right? I want to double click it and run the thing, right? So give me the .exe file. Well, the GPU needs something like that, right? And that's what the compiler does. It generates GPU specific executable state. Once this is done, the compiler's job is done. So compiler, it takes all that you give it, and it creates a machine executable thing that machine executable instructions that the GPU can understand, right? And we'll dive into, probably, in the next episode I'll dive into where all this stuff shows up in code. But I want you guys to just focus on what we're discussing and not get bogged down in actual code at the moment. All right, the key takeaway, final takeaway, the compiler exists to turn descriptions into executable GPU state, okay? So go figure, okay? All right, so the next order of business is we have to talk about what is a pipeline, okay? And where does it fit into the puzzle and stuff. A pipeline is a pre-built, immutable execution plan that tells the GPU which programs to run, how data flows between them, and how outputs are written to memory. Okay? You can think of it as a factory assembly line permanently wired for one specific job. I personally another way to think about it is, it's sort of like, you guys, you have a meeting, and at the start of the meeting there is a meeting agenda, right? So bullet point 1, 2, 3, 4. There are 4 issues we want to discuss in this meeting, and we're gonna, get feedback from everyone and discuss it and all that stuff. You know, yeah. And there's like a whole bunch of PowerPoint presentations and stuff like that. But the pipeline is the meeting agenda, and it sort of guides, the execution plan, what we're doing. So again, a pipeline is a pre-built immutable execution plan that tells the GPU which programs to run, how data flows between them, how outputs are written to memory. So, you could think of, you have your vertex shader and your fragment shader, right? And, maybe there's data that's shared between the two. Well, the pipeline will outline how all that stuff works, right? There's outputs that are written to memory. The pipeline will out that stuff, right? What programs to run. So we're running the fragment shader, the vertex shader, all of that stuff, right? So specifically for graphics, a render pipeline contains a vertex shader, a fragment shader, the output formats, pixel formats, and fixed rendering behavior. Okay, so blending, attachment count, etc., etc. The pixel formats thing, the output formats, the pixel formats thing is actually a big deal, because if the if the pixel, when you try and glue all these things together, if the pixel formats don't align properly, then it just doesn't work, right? What a pipeline does not contain. So a pipeline does not contain vertex data. It does not contain per frame buffers. It does not contain draw calls, and it does not contain window information. Those things are supplied later. It's not part of the pipeline. Again, guys, let us review what the pipeline is. A pipeline is a pre-built, immutable execution plan that tells the GPU which programs to run, how data flows between them, how outputs are written to memory. Okay, so we could understand that it wouldn't have vertex data. It wouldn't have per frame buffers, right? So like the memory or the notepad associated with each frame. It wouldn't contain draw calls, right? That's not what it's about. And it wouldn't contain window information, right? Again, what it contains is which programs to run, how data flows between them, and how outputs are written to memory. So it's sort of like stringing up the full program. That a pipeline is a pre-built immutable execution plan that tells the GPU all of these things, right? So it's an execution plan for the GPU. And then we'll get into where it appears in the code, in another episode. But right now we just want to ground ourselves on what a pipeline is, right? So a pipeline is a precompiled, key takeaway, a pipeline is a precompiled GPU execution recipe that can be reused every frame. Okay, so it can be reused every frame. So basically, you might have various pipelines, and you might want to switch pipelines for whatever reason, and maybe render a frame using a different set of parameters and things of that nature. Maybe you want to create something different on the screen or what have you, right? So you could have multiple pipelines, and then you could sort of maybe switch between the different pipelines. I don't want to mix the two. I was gonna get into. We've sort of tackled this on the Vulkan side a little bit, but I don't want to stray and confuse you guys. So I'll just leave it at that. All right, so let's get into render pass. What is a render pass? What is its purpose? All that good stuff, right? So a render pass describes where rendering results go and how rendering interacts with memory for one frame. Again, a render pass describes where where rendering results go, and how rendering interacts with memory for one frame. You can think of it as, here is a canvas for this frame, and here's how to use it, okay? So a render pass describes the render targets, textures, drawable, load actions, clear, load, clear/load, store actions, keep/discard, depth/stencil attachments, if any. It does not contain shader logic. Okay, so I'll just be upfront with you guys. This render pass stuff is probably the most challenging thing for me to understand. It seems to be a core of Mantle, and Mantle is basically the ancestor of Metal and also Vulkan, right? So this render pass conversation, it's a core theme of what, how all these graphics APIs do what it does, right? So render passes are per frame. A new render pass descriptor is created every frame because the drawable changes, the load store behavior may change, and frame boundaries matter, right? So when it says frame boundaries, I'm gonna assume you're talking about changing the size of the window, right? So if you change the size of the window, then you have to accommodate for what your frame is and all that stuff, right? Let us just kind of repeat again starting from scratch, because the render pass stuff is a little bit more abstract. So a render pass describes where rendering results go and how rendering interacts with memory for one frame. Think of it as, here is a canvas for this frame, and here's how to use it. A render pass describes the render targets, for example, texture/drawable, load actions, for example, clear/load, store actions, for example, keep/discard, depth stencil attachments, if any. It does not contain shader logic. Okay, render passes are per frame. A render pass descriptor is created every frame because the drawable changes, load store behavior may change, frame boundaries matter. We'll get into where it appears in the code at a later date. Key takeaway, a render pass defines the frame buffer and memory behavior for a single frame. So a render pass is more, it's a more granular level. It's like more on the ground level, and it's dealing with the per frame, it's dealt with on a per frame basis. So render pass for the previous frame might be different for the render pass for the current frame, and also the render pass for the current frame can be again different from the render pass from the two previous frames, right? So the most difficult thing to understand, I know in certain circles, for example in Vulkan, I know that they're trying to move away from render pass stuff, but I'm not really in a position right now to sort of dive into that conversation. But I know they're trying to make an effort to move away from render pass stuff and deal with a thing called dynamic rendering, but I digress. Let's not So sort of let's glue all of these things together, right? So we talked about the compiler, we talked about the pipeline, we talked about the render pass, and the whole point of all of this is basically to produce a frame on the screen, right? Frames per second. That's a metric that all computer graphics applications and computer graphics hardware is measured by, right? How many frames per second can you produce, right? 60 frames per second is ideal. I think the eye can at a minimum it's 30 frames per second for the eye. 60 frames is ideal, and if you get higher than 60, then you have silky smooth graphics, right? So the end product of all of this, and why we even do all this stuff and why all this stuff exists, is to put a frame on the screen, right? whether you're talking about a video game or straight video, right? You're recording video, um, and that video is basically, it's a stack of frames. Okay, so how does all this stuff come together, right? So at the core you have the compiler, right? And the compiler produces the pipeline, which uses the render pass, which executes during each frame. So maybe I used the language wrong. I'll say it a little different. Let's say it's a skyscraper that we're dealing with, and we're going down floors to the ground floor, right? We're at the penthouse now, and we want to get to the ground floor. So at the penthouse we have a frame, right? And the frame is basically what we see on the screen, right? So there's a lot of things that have to happen in order for you to see that frame on the screen. So that frame is at the penthouse level, right? Associated with the frame, right underneath the penthouse, is the render pass. Now the render pass, executes, during creation of the frame to actually make the frame do what it does, right? So right below the frame we have our render pass, right? And this render pass, below the render pass now, it's the render pass instructions and everything that the render pass does is baked into the pipeline, right? And remember now, the pipeline is the execution plan, right? It's the execution plan for the computer graphics application, right? It sort of harnesses everything together, puts it together in one execution plan, so that it's easy for, it's a one-stop shop for the instructions of how everything needs to be done, right? So we have that pipeline, which is another floor below the render pass, and it's a couple floors below the frame, right? And then on the ground floor, where you could basically walk it on the street side, and you could literally go into that first, it's like the lobby of the skyscraper. You have the compiler, right? And basically what happens is that you have the pipeline, which basically, in the pipeline, it sort of bakes everything. So let's say the pipeline is on the second or third floor. It bakes in all the frame and render pass and everything above it into a nice little package, and it hands it over to the compiler, right? And what the compiler does is basically, takes the human readable stuff, right? That with all the instructions, the pipeline stuff, the render pass stuff, what we want to do with the frame and everything. And what the compiler does, it changes it from human readable stuff into machine level code that the GPU can actually run the execution plan, right? That's the way I like to think of it. I want to do a quick thing of what consumes what, right? So we have an object, we have what it consumes, and we have what it produces. Okay, so we have the object of the compiler. It consumes shader code and pipeline descriptors, and it produces a pipeline state. That's a little bit confusing, but basically it takes in the code, the shader code, all the pipeline stuff, and basically it produces something that the GPU can read, okay, and execute, right, and actually perform work and do stuff, right. The GPUs aren't made for its decorative powers. It's made to actually do stuff, right, and it tends to get hot when it's working really hard. So sometimes you need to have fans associated with a GPU, but not with the Apple GPU, because some of the computers don't have fans. But I digress. Okay, so the compiler consumes shader code and pipeline descriptor stuff, and it produces basically language that the GPU can use to do its work. Okay, so let's start with the next one. The object. The object is the pipeline, right? What does a pipeline consume? The pipeline consumes render pass and draw commands, okay? So this is sort of our graphics, the graphics pipeline, what is it we're about? What is it that we want to do? And it produces GPU execution. So it's sort of, if you will, it's a human readable version of what we're trying to tell the GPU to do, right? Um, it's a human readable version of what we're trying to tell the GPU to do. But we have to write out all this stuff with code, right? So that's what the pipeline is. So again, the pipeline consumes render passes and draw commands, and it produces GPU execution, right? It doesn't produce machine code, but it gives us the GPU execution plan in a human readable format, if you will, right? And then we have the object is render pass, and what does it consume? It consumes pipeline outputs, and it produces frame buffer content. So the way I like to think of it is that basically the render pass is sort of the last thing that basically makes the frame look nice and pretty. So think of yourself as a painter, and you're painting frames, right? The render pass is basically in charge of that, and it's sort of at the second to highest level in terms of abstraction, right? And then finally, you have your frame at the very top. And the frame is just a frame. It's what we see on the screen, all of that good stuff. Let's just do a quick overview. Again, the compiler translates shader code and pipeline descriptions into GPU executable state. Number two, the pipeline is a precompiled immutable execution plan that defines how the GPU runs shaders and writes outputs. The render pass, a per frame description of where rendering goes and how memory is used. Order of operation, the compiler creates pipelines at startup. Pipelines are reused every frame, and render passes provide the per frame destinations those pipelines write into. Okay, let's do a quick sort of quiz, if you will. And you'll have to intellectually decide what exactly is going on. So if I'm defining behavior of my execution plan and everything, what is that? I'm defining behavior. If I'm defining behavior, that's the pipeline. If I'm defining memory for this frame, so the memory that I'm using for this frame and all that stuff and what I'm referencing, the memory for this frame, that would be the render pass, right? I'm turning descriptions into executable state. That would be the compiler, okay? And that's pretty much it for today, guys. It's really important for us to understand this stuff, because once we dive into code, it's gonna get really noisy and messy, and different files we're jumping into and out of, and we need to have a mental model of what's actually happening behind the scenes so that we don't get lost in the shuffle. So I hope you guys enjoyed this video. This is Cuda Education. Like, subscribe, share. It's we're still early days in 2026, so make a commitment to yourself to learn Metal in 2026. By December of this time, we should be well versed in the ways of Metal. And remember, learning Metal can help you because you're literally like interfacing with the GPU, right? So learning Metal will give you open doors for you in terms of artificial intelligence, machine learning, deep learning, LLMs, and of course computer graphics itself, right? So definitely, take it seriously. And time is expensive, so use it wisely. Thank you guys for watching. Have a great day.